All right. Good morning, everybody. So my name is Harish. Uh, so I'm going to talk to you today about looking into the future. What do we have in store in the future of autonomous systems, and more specifically, I want to think about what can go wrong, right? So, uh, and then how do you even start to think about testing these things? Because as I will talk about, there are so many different applications for autonomous systems, including mass. Then so when we're trying to build a methodology to test these things, we have to try and think about the big picture, like all the different things which can go wrong, and how do you come up with a system to test all different aspects. And I'll talk more about this. So before I go, you may be wondering what Florida Polytechnic is. We are a relatively new university. If you're driving by I-4, if you see something like that, you can miss it. That's us. And my marketing team will kill me if I don't show you this. So there are a few facts about this. Apparently, it's designed by a famous architect, Calatrava. So we try to boast about this anytime we get an opportunity. Uh, so Advanced Mobility Institute, that's where I belong to in Florida Poly. So our mission is to build an applied research center to build capability for testing autonomous systems, right? And we primarily want to go about that by building partnerships with industry, because we need something to test if you want to build a testing system. And and traditionally, even all the government agencies which fund ITS systems and autonomous vehicles, they tend to use universities as independent testing agencies. So we want to look ahead and see what are the different aspects of testing there can be, and position ourselves where we have that capability. Okay. So again, why autonomous systems? I don't want to repeat everything which people already said about this. There's a few things. Most of our vehicles are at this point in rest or parking for most of the time. We want to make use of them more efficiently. More importantly for me, my concern is about the number more than 33,000 road fatalities. And I think Eddie said something like 40,000, right? Right. And then that's a big number. And most of them happen because of human error, right? So anything we can do in this space to increase the safety of people, we can save a lot of lives, right? Ultimately, as a faculty, as a professor in electrical engineering, my view of technology is, not only to help industry make money, but to help, improve people's lives, right? So, but on the other hand, our tolerance to human errors is much higher than our tolerance to robots or autonomous systems. So if we want to see a future where we have autonomous vehicles, then it is important for us to build trust and confidence that they will be safe, right? Unless that happens, we probably will, governments are not probably going to give license or, allow complete autonomous vehicles. Okay, so before I go into talking about how do we actually build a testing system, I want to talk about the different aspects of mobile systems, automated mobile systems. So first, again, as all the speakers already talked about, mass and robot taxis. These are obviously a clear possibilities in the future. So I have two categories of applications here, and obviously these are not exhaustive. On the left-hand side, I have clear path. I'm saying clear path because we sort of know why we will need these things. We sort of know all the technology we need to get there. So these are on the left-hand side. First, robotaxis. Warehouses is much more clear path about using autonomous mobile systems in warehouses. Amazon's already using it pretty heavily, and then it's been using it for like over 6 years now. Human care. This is an interesting aspect of autonomous vehicles. So I'm saying autonomous vehicles because these are autonomous systems which are mobile, right? And it's, I was in ITS America conference last in DC, and it was surprising that was a whole section devoted to autonomous systems for elderly care and care for disabled people, right? And so when we talk about mobility as a service, well, if you're providing that service for able people, we have different needs than if you're providing service for disabled people, right? So how do you account for the needs for disabled people, and how do elderly people and disabled people interact with autonomous vehicles? That is a completely different area, and that's why I'm categorizing that as a separate aspect of it. And obviously warfare, that's a whole big topic by itself, so I'm not gonna go much deep into it. So on the right-hand side, I have not so clear paths. So this is because at least in the industry, there is not yet well identified need for these things, and we don't know very clearly whether they're going to happen or not. But there is a possibility. So first is I want to talk about energy trading and data warehousing. So as Pete was saying, we probably won't have parking lots in the future, probably. But electric vehicles still have to charge. So they have to go to a charging station. And unless our charging technology improves drastically, they're going to take some time, right? So while they're doing that, they're at rest, right? And they have, so with the rest, and they have very valuable resources. One is battery, and two is powerful processing systems, right? So, I mean, you can use them as batteries, like, for example, offloading energy during the peak time and using them during the low time. They have powerful processors, so they can be used as cloud computing devices, especially if they're connected. So there is a whole aspect of that area which has not been explored into, but I'm thinking in the future it's going to happen. But in the industry, in the academic literature, this area has been explored very well. And two, mobile weather stations. We actually currently have lots of mobile weather stations, but they're driven by humans. And for that reason, we don't have a lot of them, right? And most of these mobile weather stations are funded by government agencies, and they're usually not very well funded. So, and if you want to use humans, they don't have many, right? So in fact, at this point, believe it or not, we don't have a very good method of validating satellite data. There's a lot of meteorological information we get from satellites, and it's very difficult to actually validate, so we just have to trust them, right? So the one way to validate is have ground weather stations, and the higher the density of these weather stations we have, the better it is, to validate. And I'm assuming it's going to be more and more important in the future, especially if you want to predict precise locations for hurricanes. So if mobility becomes cheaper, we can have more of them, and there could be a big industry surrounding it. And then finally, I want to talk about robotic swarms. Again, Amazon is already exploring it from delivery perspective, and we can have lots of other applications such as construction, and there's a big load of applications out there. And obviously, these are not exhaustive applications. So I wanted to talk about all these different sort of applications because I wanted to give you a scope of different things autonomous systems can do. And a single vehicle or single mobile system can do multiple of these jobs. So if you want to build a testing system, we want to build a testing system which can test all these different aspects, right? Okay, so let's see. Okay, it still doesn't seem to be working. Okay, there you go. All right, so if you step back and think about autonomous systems, we probably can characterize all the different components into three main categories. First, we have sensors. Second, we have algorithms. And third, we have interactions. Okay, so most of the systems, they're a combination of all this stuff. And sometimes it's difficult if the boundary between these things is blurred. For example, most sensors which you buy come with inbuilt algorithms. So therefore, you cannot really separate sensors and algorithms that way. But if you look at the system as a whole, there are these three different aspects. First, let's talk about sensors. As Clayton was talking about and Pete was talking about, we have so many different kinds of sensors. So we have cameras, lidars, radars. In future, there could be a lot more. Okay, so let's think about these vehicles being tested currently. You see, many different companies already testing autonomous vehicles. So they have a radar or lidar on them. But let's say in the future, all vehicles have radars on them. right? So at this point, when you have a radar and then you have an antenna which is collecting the return signal, there's only one signal which is trying to collect. In the future, let's say if all vehicles have radars on them, there will be multiple signals. Okay? And there are ways to combat that. That's how cell phones operate too. But then there's still, even if you have that, there's always interference between each one another. If you have lidars, if all vehicles or multiple vehicles have lidars, there's a heavy concentration of laser in that frequency in that area. So we don't know what the result is going to be. If there's a single vehicle working properly, it may happen that multiple vehicles may not work properly. Okay, so and then you test let's say you have 1 million miles of driving testing. Of that, you have 2,000 miles of driving in snow. Does that mean you really tested it? Probably not, right? So you want to make sure that, in fact, if you want to actually have 1 million miles of snow testing, you either go to a place where it's always snowing, or you build a system which can input snowy images into the car and see how it will perform. Right? So this is where we are building this, what we call a hardware in the loop, where we are building a system where we can provide artificial data to the vehicles and see how they perform. Right? So we can simulate different environment and see how the vehicle performs, basically. Okay? So that's about sensors. So let's look at algorithms. Okay. So think about these autonomous systems doing, they're getting all the data from the sensors, and they have to, first of all, interpret what the data means, and then make some decisions, right? So let's say there's a human, there's an autonomous vehicle driving. Think about what's in the surroundings. There are other vehicles. There are probably humans driving that vehicle. So a very basic part of making a decision is first you have to predict what's going to happen in the surroundings in the future, and then make your decision accordingly. So now we're in the process of predicting what other humans are doing, right? We are in the process of how maybe there's animals, there's some other objects. We're in the process of predicting how these are doing. So there's a very complex process of complex processes going around, and the system has to try and predict what's going to happen. So if you want to test it, we have to create these complex scenarios and input these scenarios into the vehicle, right? So that's first human in the loop kind of thing. Second is training. So let's say if there's a vehicle which is based on image processing with cameras, there are lots of data analysts and machine learning people who are training these classifiers, right? And I'm sure many of you have heard about in the news, for example, there are many image recognition algorithms which don't work well based on skin colors, right? They're only trained for a certain skin color. My phone, Siri, until recently didn't recognize my accent, right? So it's because the people who trained Siri don't have this accent, right? So there could be all sorts of biases which are inbuilt into the people who are designing these systems. So then again, if you want to build a testing system, we have to make sure that we catch these biases, right? Finally, I'm going to talk more about interaction. But when you're talking about algorithms, you also want to test if the algorithms take into consideration all the ethical issues. Again, so from a testing perspective, we're not going to decide what is ethically correct or not, but we want to give a capability of encoding ethical issues into something which a computer can understand, right? So there's all sorts of ethical issues when it comes to autonomous vehicles. So, for example, do you want to save your passengers or do you want to save pedestrians? Do you want to, save? Can you, if you have a chance to save 3 people by swerving and maybe hitting another person, do you want to do that, right? So there are all this, again, from a testing perspective, we don't want to be in a position to decide what is ethical or not, right? Again, so we probably leave that to regulators or whoever wants to test their systems. But we want to provide a mechanism for them to actually encode these different aspects into the testing process. So finally, let's talk about interactions. Okay. So interaction. So Clayton gave a very interesting anecdote about what happens, when the autonomous vehicle, because of its safety constraints, it stops suddenly. But let's say you are a human driver, you're behind that vehicle. So when we are driving, we anticipate what others are going to do and drive accordingly, right? So if we think there is a human driver in the bus, we wouldn't anticipate them to brake suddenly when nothing's happening, right? But autonomous vehicles may, right? So we as humans, when we're driving, we have adopted to all sorts of signals on how other vehicles behave, right? Sometimes, there are some cases where you may actually, when you don't have your signal working, you may actually put your hand out. Can the autonomous vehicle understand that? You don't know, right? And then let's say think about, let's say, company A, which is doing, there's programmers in there, they're programming on how to make decisions. Right now, when they're programming, they have these probabilistic models on how other vehicles are behaving. And those models are built on observing human drivers. But in the future, let's say if all vehicles are autonomous, they're built by many different companies. Each company has its own algorithm, right? Even a single algorithm is difficult to predict in different scenarios. But now there are multiple algorithms and multiple scenarios, right? So how do these vehicles interact with each other? In fact, we may actually have let's say if we are going into mobility as a service, there is a certain cost for time now, right? So now different vehicles may actually compete with each other. And the companies who are building them may actually program them, in order to, when there are no passengers, you want to take risk and go at high speed. They want to program them to compete with other vehicles. So in that cases, they're interacting differently. So again, then how do you, again, maybe this is where regulations come in too, on how do you actually dictate how autonomous vehicles should behave, right? Another example, let's say there is an emergency vehicle, right? So we know how to behave when there's emergency vehicles going. Do autonomous vehicles know that, right? And when we see an emergency vehicle, we know, okay, everybody else is trying to go to a site. Do autonomous vehicles know that? Again, if you're testing a vehicle for 1 million miles, how many of those miles have you encountered emergency vehicles, right? So in this area, then we are trying to build a language for vehicles, right? How do you even define a language for vehicles? So far, we have all these implicitly understood notions. So we have to start, formalizing all these notions and build a language and see if, vehicles are following this language and how they are dealing with this language. Okay. So let's see. So finally, I want to end with giving a few examples. There you go. So this is one of the projects we're working with Miami Police Department, where we are helping them, automate some of their vehicles at the same time, test them, and so this is the case where the autonomous vehicles has very specific needs. So there is a police officer sitting in there. Usually, a police officer in a car is doing a lot more stuff than we do in a car. So they have to pay attention to many different signals. So how do you actually make an autonomous system? And again, this will not be a complete autonomous system. It'll be a semi-autonomous. Then when we are testing the system, you cannot test as if there is a normal human who's completely attentive on the driving. We have to test assuming there's a police officer and is doing 3 different things while driving, right? So there are different things you need to think. So I think this project will give us a lot of experience on how do you take care of these edge situations. Let's see. So finally, this is a part of our team. Actually, there are a few people missing in here. I just want to say we are a very multidisciplinary team. On the top left, Dr. Rahul Rasan, he is our strategic director. He has played a big role in establishing the institute and building it forward and building industry relationships. Dr. Akbas, He is right now in Embry-Riddle, Embry-Riddle Aeronautical University. We have an MOU with them, and they're into all sorts of aerial vehicles. So that will be a good partnership for us to try and test aerial vehicles. Dr. Arman Sargozai, he is right now our research director. He is leading all our research missions. So I just want to summarize. So we have some mathematicians, Dr. Al Nasser. He is working on formalizing from a mathematical perspective how to formalize the notion of language. We have Dr. Suleiman Alspois and Dr. Vargas. They are experts they have expertise in RF design. And so they are working on EMI, electromagnetic interference, and things like that. And finally, me, I'm also more of a theoretician myself. So I'm also working on the cooperative algorithms and the mathematical notion of language. So having said that, let's see, that's our institute, and our website is right there. I would encourage you guys to go visit and look at all the different projects we are working on. So thank you.